Good morning, everyone.
Good morning.
Yeah, so we'll wait for others for about 10 minutes. Then after that, we'll begin. Hello, so I think we'll start since I'm seeing the number 28 is a lot. Yeah, then some will come and join us. Yeah, so I think we'll start. So before we start, I will pray. So shall we close our eyes and pray? Our dear Heavenly Father, we come before you as sinners. Oh God, you know that we can't do anything. We can't do anything, oh God, if you are not there with us, oh God. Oh God, asking you to be with us, to be as we start with this lesson, oh God. As you unveil the nature of God, to be with us and help us to understand, help those who I'll be teaching to understand each and everything of God, and help me to speak, to impact wisdom in me, so that I might speak things which they will understand, oh God. For I know that without you, I don't possess any wisdom, oh God, and the little knowledge which I know, God, let me impact it into others, oh God, so that they might learn something and they might also in turn teach others, oh God. God, I'm asking you to be with us and to be amidst us as we start this lesson, oh God. In the name of Jesus we pray, amen.
Amen.
Yeah, so today we are starting a very interesting topic, structure electronic. Yeah, and before we start, there's something which I want to say. I want to say thank you for all those who did the exercise. I bet after doing the exercise, the things were even more clear now. Yeah, so we learn by doing exercises, and if you do an exercise, if you try it, you get it wrong, you try it again until you get it right, you will never forget things which you have done yourself. And it's really amazing which you did. It was really amazing to me. Yeah, because in trying, there are some who found other ways of finding abundance in such a way that they used the one and the abundance came out. So that's all about learning. Learning is not me teaching you. It's you yourself sitting down, doing the exercise and understanding the topic by yourself. So learning is teaching yourself, not me teaching you. Yeah, that's all about learning. So I want to thank each and everyone who did the exercise. And I think everything now is cleared, like you know where to use this formula, you know how to use that formula. So basically, chemistry is about solving. They don't really define what is an atom or define what is what, but they deal with, the chemistry deals with solving. So if you are good at solving, you will definitely make it in chemistry here. Yeah, so continue with that, and I hope these other topics you understand. Yeah, and you'll be able to answer some questions which I'll give you after this topic. Yeah. So a bit of recap. At first, we started by looking at an atom. Yeah, an atom itself. We defined what is an atom. We saw what is found in an atom, and we defined what is default mass. All that, we looked at all that, and there's a remark which I want to say on. When you are using that formula for energy is equal to mass times energy is equal to mass times C2. That one is only used when you are calculating energy in joules. Yeah, that formula is only used when you are calculating energy in joules, this formula here. I hope you can see.
Yeah.
Hello. Yeah, so it's only used when you're calculating in joules. So use this one when you're calculating in joules, and you have to change your unit, your default mass, which is in unit mass atomic, to kg. So when you change it to kg, you calculate your energy in joules. Then after you calculate your energy in joules, that's when, if you want to turn it to to electron volts, you just have to equate it. You know how you can equate it, and after turning it to electron volt, then that's when you can turn to mega electron volt. This is the one way of going to mega electron volt. Then the other way is equating throughout. You start with a mega electron volt where you just get the default mass in UMA, then you just equate it. You know, one UMA is equal to 931.5 mega electron volt. Then you find the mega electron volt, then you continue equating 10 to the power 6 electron volt is equal to 1 mega electron volt. You continue equating. So that one is finding energy by continuously equating. But this equation is, if you prefer to first find Joules, then you equate to maybe electron volts and mega electron volts, because those all of them, Joules, electron volts, and mega electron volts, all of them, they're energy. Yeah, but Joules is bigger than mega electron volts, and mega electron volt is bigger than electron volts. That's what you should know when calculating. Yeah. So all that, we'll continue with our lesson today. So we're starting a new topic, which is structure electronic. There's atoms, theory classic, and the Untitled. So for today, we'll just do theory classic. So when I say theory classic, so I will just give you a hint. So in theory classic, basically we'll be doing with mechanic classic. Mechanic classic, this is a theory in physics which describes the movement of an object, and that movement of an object must be less than the speed of light. So theory classic, it is a theory which was just set up, and these people, we see Rutherford and Bohr, will use this theory classic to describe an atom to us. So they'll be using this theory classic, the knowledge which they have for the theory classic, the knowledge of the movement of objects, how objects move. So theory classic, it talks about the movement of objects, how objects move. So they will do an experiment, and according to what they studied under mechanic theories, they will tell us their views on how they see an atom to be. Then theory on the Untitled, this one is they will study an atom in such a way, they will study an electron in such a way that they will try to verify us that they will try to tell us that this electron is in form of Untitled. It means a wave. This electron is in form of a wave. So we'll look at all that in future. For today, we'll just look at theory classic. How did they describe an atom according to theory classic? Yeah. So to begin with, we'll begin with the model of Rutherford. So model of Rutherford. Yeah, actually, model of Rutherford is very interesting model. So we see that just what before I read this. Yeah. So we see how Rutherford described an atom according to theory classic. So this is just concentrate on I want you to concentrate on the experiment. We are not using this book, but this is the book. When I was making the notes, didn't get the diagram. So I want you to concentrate on this experiment. So Rutherford, with his friend Master Ginger, they wanted to know what an atom is really like. What does an atom like? How is an atom arranged? That's what they really wanted to know. So what they did is, they got something like I can say a container which is vid, something like a container which is vid, and in this container they placed a radioactive particle which emits particles, alpha particles, and they had placed some two focalizae. these two which you are saying, D1 and D2, they are just making the beam, the beam of the particle to move in a straight direction. Then they also got a sheet of what? A sheet of gold. So when a sheet of gold, which is very, very thin. So what they did is they beamed a particle into this sheet, and here there's a screen which is recording everything. This is a screen which is recording everything, the particle which passes, all that. So they got a beam, and they got an alpha particle. After getting an alpha particle, they beamed it into a what? Into a sheet of gold which is very thin. So what surprising, they were started to observe that there were beams which were passing through. Yeah, a lot of beams were passing through. If you can see here, a lot of beams were passing through. Then there were some beams, few beams which reflected, like they went back. So for them, they were surprised in such a way that they found out that when they directed this beam into the sheet, which was very thin, they discovered that a lot of beam passed through, and very little of it was reflected back. And they also discovered some were deviated, somewhere they were diffracted, and some were passing straight, all that. So when they came to conclusion, after discovering that a lot of beam were able to pass through, they concluded that an atom actually consists of a space, an empty space, which makes the beam to just move in and to go and to be recorded on the screen. It consists, the large part of an atom is just an empty space. The large part, so they concluded that the large part of an atom is an empty space, and also the smaller part of an atom is the its mass is concentrated on the smaller part of an atom, and the smaller part of an atom, which is in the middle, is positively charged, because we know that alpha particles are positively charged. For them to be reflected, meaning like them they reflect, and then like them they retract. So for them, they concluded that since it was reflected, it means that an atom, its mass is concentrated on the center, and the center is positively charged. That's the ion, which they already know that the ion is positively charged. Then what they did again is they tried they tried measuring the intensity, which was recorded on the screen here. After they measured the intensity which was recorded on the screen here, they found that the intensity which they recorded, which was on the screen here, when there was a sheet, it was the same as the intensity which they measured when they removed this sheet. So they discovered that an atom is natural. An atom is neutral in such a way that it has same number of electrons and the same number of protons. And for it to be neutral, there must be there must be mechanical stability. Mechanical stability in such a way that the force of attraction, the force which is attracting the electrons, and it must be equal to the force of centrifugation of an electron. The force which is making an electron to move must be equal. So that's what they observed. So they observed that an atom has got a larger space, an empty space in it. I've seen your question. An atom has a larger space on it, and they also discovered that since a little part of the beam was deflected, its mass is concentrated on the center, and the center is positively charged. And they also discovered that when they removed when they have put the beam and when they removed the beam, the intensity which was recorded on the screen was the same, meaning the atom generally is neutral, such a way that the number of protons and the number of electrons are equal, and it gives us 0, which which makes us possible to say that these electrons must be around the nucleus. Yeah, so that's all that. That's all that about. Okay, I'll definitely do that. But just like you should be passing through the book. I'll definitely, someone asked if I can share the book. I'll definitely share this book, and yeah, I should. But don't. If you just to check it, your main book is the one which I'm sending to you. So that's how they discovered. So that's how they discovered about about an atom for themselves. Yeah. So with that experiment, we'll continue with our model de Rutherford. So according to our experiment, they discovered that the charge positive of le charge positive de l'atome était concentré dans son noyau. So they discovered that the charge positive of an atom is concentrated on its noyau because less beam was reflected. Then Rutherford a supposé que les électrons sont disposés autour du noyau à une distance A et sont animés d'un mouvement circulaire uniforme. So Rutherford supposed, like he supposed that the electrons were disposed around the nucleus at a distance, at a certain distance r. R simply means the radius, like the radius from a noyau and the electron. You know how electrons and noyau they are located like around the nucleus, and their movement, and they had a circular movement which was what uniform. So animé d'un mouvement circulaire uniforme. So that's what was that's what was his discovery. In such a way, he supposed, hello?
I've got a question.
Yeah, you can ask.
The empty space that you are talking about in an atom, is it the space between the nucleus and the orbitals, or what?
Yeah, exactly. Yes, the one.
All right, thank you.
You're welcome. So the space, so someone asked the space for the space which I was talking about. The space which I'm talking about is the space between the nucleus and the electron. So we said he discovered that an atom is positive, and he also supposed, according to the theory mechanic which we learned, he supposed that the theory mechanic which I told you, which is a theory which describes the movement of objects. For him, he supposed that for an atom to be neutral, meaning there must be electrons which must be disposed around the nucleus, and these electrons must be at a radius r, at a distance of radius r, and these electrons must move uniform. So les électrons sont soumis à une force colombienne du noyau qui devrait les attirer, par conséquent, ils sont soumis à une force de composite qui s'oppose à l'attraction du noyau. So these electrons to be maintained in movement, they are put under a force of Colombian. This is the force of attraction between a noyau and the nucleus. So a force of attraction between a noyau and the nucleus is a force Colombian, and there must be a force to compensate it. You know, if someone is moving around in a uniform, there must be a force attracting it, and there must be a force opposing it in such a way that it will be on a medium, such a way that it won't, like when it's moving, it will be moving in a uniform what? It will be moving in a uniform uniform circle. Yeah, it would move in a uniform circle. So first thing, we discovered that an atom contains a nucleon, which is nucleus, which is positive, and the electrons are disposed around, and there are two forces. The force there is a force of Columbia, this which attracts an electron and the nucleon, and there's a force of compensation which opposed to this attraction between the nucleon and the electron. That was the discovery of Rutherford. So, according to Rutherford, for him, this is just a description. The nucleon was positive charge. The electrons were disposed outside the nucleon, and so the nucleon is represented in red. The electrons are represented in green, and the distance of the nucleon and the electrons say note r. So this distance from here to here is note r. It's r. And the movement secured the electrons animé par kinetic energy et force colombienne. Attiré et force compensation supposed. So kinetic energy, this is kinetic energy. You know about kinetic energy, the energy which makes something to move. And force colombienne, this is the force of attraction, which is opposed by the force compensation. So the force of compensation, these are the force which usually oppose, so that the thing continue moving in circulation. So la théorie classique exigeait, la théorie classique, the same théorie classique of Rutherford, exigeait qu'une particule en mouvement dans un champ électronique encadre une onde électromagnétique, donc rayon de l'énergie. So we see that this theory classique, as we describe the theory classique, this is a theory which describes the movement of an object. And according to theory classique, if you go deep in theory classique, which is basically us will never go deep, but if you go deep in theory classique, you understand that in theory classique, it states that when a particle is in movement in a electromagnetic, in an area electromagnetic, basically, it is an area where there is positive, where there are charges, and there are charges, opposite charges, and there are also movement of those charges. So we see there's a movement of electron, which is a charge, and there's a positive charge, which is attraction. So the movement of a charge, which generates electricity, and the nucleon which attracts it, thus it creates an area of electromagnetic. So we see that according to theory classique, if a particle is moving in an area of electromagnetic, it generates it means generate an onde. It generates a wave electromagnetic which radiates radiates some energy. So if a particle is moving itself, so Rutherford said an electron will be moving around the nucleon. Then theory classique is telling us that if a particle is moving, it means it radiates some energy. There's some radiation which are lost in form of energy. And this energy is la energy transportée par ces rayonnements est perdue par l'électron. So this energy which is transported by this radiation is lost by the electron. So according to theory classique, an electron is moving and an electron is releasing some radiation, which means it is losing some energy. So when an electron is losing some energy, there's a problem where that there are hydrogen conduit donc à. So when an atom, an electron loses an energy, is losing energy. Yeah, let me attend to your question. Yes, Colombian, someone asked, is Colombian force same as electrostatic force? Yes, Colombian force is just the same as electrostatic force, since electrostatic force is the force of attraction between two opposite ions or opposite charges. So it's just the same, like we see electron is a negative charge and the ion is positive charge. So they attract each other. Yeah. So I hope I've answered your question. Yeah. So to continue, I said that each time an electron is moving on itself, it releases some radiation in form of energy, and this radiation, this electron, it loses. Actually, this electron, it will be losing energy. So what's the problem which is created here? This is the problem which Rutherford never foresaw or never even thought of. So the problem was cette mode appliqué à l'atome de hydrogène conduit donc à l'émission continue de rayonnement. So as this electron is moving on itself around the ion, we'll see that it will be what? It will be losing energy. It will be losing energy in form of radiation, in form of emission. Emission of what? Emission, continuous emission of rayonnement. And if it is losing energy in form of continuous rayonnement, we'll see that this electron definitely, what usually happens if you lose all your energy? Some usually they lose their power. Some even faint. Some are what's I've never seen a case of some dying. But when an electron loses all its energy, it means that electron will definitely die. And if that electron dies, there will be the destruction of an atom, because each time this is the second point we say, la destruction de l'atome. Lorsque l'atome rayonne, son énergie diminue. Yeah. I don't know, someone is asking if I can repeat, starting from Theory Classique. Did you come late or what? The person was asking. Hello? Okay, so someone was asking if I can repeat. I don't know if it's okay with all of you. I need the response. Is it okay I repeat or what?
Yes, it's okay.
It's okay. Oh. Okay. Yeah, so actually he wanted us to repeat on La Theorie Classique XJ. Yeah, so here I mean, so we have discovered, like Rutherford has discovered, quite all right, Rutherford has discovered an atom that it contains space, an empty space. But the mistake which he made, he said that electrons themselves, they are moving around an ion. And according to the Theory Classique, we said that, to me carefully, Theory Classique comes from Mécanique Classique, which says that this is a field of physics which describes the movement of an object, and that movement of an object must be less than the speed of light. So if you study deep in Theory Classique, you understand that according to Theory Classique, when a particle is in movement, like when a particle is in movement in a champ electromagnetic, I said champ electromagnetic is an area electromagnetic where you find the charges, different charges. So when this particle is moving around the champ electromagnetic, it generates, an onde is generated. Yeah, we see an onde or a wave is generated, and this wave is in form of energy. It is radiated in form of energy. So here, what particle is moving? Electron. So we see that if this electron is moving, as Rutherford was saying, according to our theory of mechanics classic, it means that this electron will be radiating somewhat, will be radiating some, there will be radiation which will be lost in form of energy. So now the question was, what's the problem with it? This, like, what's the problem of losing energy? So this model, this is when we come here. This model applique à la hydrogen conduit à donc à. So this model, which is applied to the atom of hydrogen. So from here, like, I want also you to know that from theory classic to theory on the other, we'll be only talking about an atom of hydrogen. Like, that's what they thought it was easy, because hydrogen has one electron in its outer shell. So they were just using an atom of hydrogen to discover their discoveries. So cette modèle applique à l'atome de hydrogène conduit donc à l'émission continue du rayonnement. So we see that this model of this classic model, which this classic model which we have described, it tells us that if this electron is continuous moving around the noyon, it means there will be also continuous emissions of radiation. And if there's continuous emission of radiation, we have said that this radiation is lost in form of energy. And if there's continuous emission of radiation, it means that the energy will be what? Will be lost continuously. And if energy will be lost continuously, if you have no energy, you definitely faint, or some people die, or all that. We see that the electron itself, it will lose its power, and it will definitely die, and it will lead to the destruction of the atom. Since we see it leads to the destruction of the atom, because an atom, it will radiate, and its energy will what? Diminish. So energy diminish. So that's what basically about the first part, the first page. So he discovers, and in his discovery, he didn't consider this problem which would come out. So I don't know if you are clear on the first part, so that we move on the second part. If you have questions, you can ask on the first part. Okay. If you are clear now, we are going on the second part. Now things are getting more interesting.
I have a question.
You can ask.
It's on the part when an electron loses all its energy and it dies out. Does it really die out, or maybe it doesn't lose all its kinetic energy?
That question is like, it really dies out. It really dies out, like it loses all its energy, and actually it dies out in such a way that, one, it will stop moving, and two, it will form. So this is not something which was actually proven, but it was something, I can say, an assumption that an electron will die according to the mechanics classic, which is studied. Like there's mechanics classic, there's a theory mechanics classic. If you have time, you should search about that. According to what he studied, that's how he was governed, according to the things which he studied. So it's according to mechanics classic, the atom dies actually, but physically or truly, they never really know what really happened. It was just an assumption. I don't know if you get me.
Okay.
Yeah, so it was just an assumption that an electron dies, and this electron will definitely be destroyed or die. So now we have discovered that this electron, it moves around a nucleus, and if we want to calculate, so they went further Rutherford went further in. Now we'll be talking of how to calculate the total energy. Yeah, the total energy. We'll be talking how to calculate the total energy. So these people, they went further calculating the total energy. Yeah, and that problem actually, it is not yet solved, but for now we'll just put it aside and we see how to calculate the energy. Then later we'll see how to resolve that problem which Rutherford could see but could not know how to observe it, to resolve it. So how do you calculate total energy for this electron which is moving around the nucleus? So these are things which you know. So we know that according to the physics which we learned back home, we know that total energy is energy kinetic plus potential energy. We know all that. So this is the formula for kinetic energy, and this is V is for potential energy. So energy potential. So we know that that principle that energy is what is not destroyed, but is what is transformed from one form to another. So we see the total energy. If an electron is moving, an electron will always have kinetic energy and the potential energy, because it's moving in a uniform form, as we discovered. It's moving in a uniform form. So for us now, we want to calculate the total energy, and for us to calculate the total energy, there are some things which we have to do, and we have to determine our V. We don't know what our V is. We have to find what our V is. Then after finding out what our V is, we have to do something with our kinetic energy, so that we create something similar with our V and D, so that we want to create one equation in such a way. We want to create an equation which will be one. So how do you deal with, so first we deal with the potential energy. So how do you deal with the potential energy first? So the force Colombian, so as I said earlier, the force Colombian is a force of attraction, and someone asked, is the force Colombian is the same as electrostatic force? Yes, it's the same as electrostatic force, the attraction between two negative charges. So we see an electron which is negative charge and a nucleus which is positive charge attracting each other. So the force Colombian. So the force Colombian is given to us. This is something which is constant. This is something which it was already solved for us, and they gave us, this is force is equal to 1/4 pi epsilon. Epsilon, this is epsilon. This is simply a zero, like epsilon is epsilon. It was supposed to be a small zero down here, times E2 over R2. So why did they bring the force Colombian in it? So energy potential. So energy potential, you should understand that energy potential depends on the position of something. If you hold something, imagine you hold something, the position of that thing, that's where the energy potential depends on. So the force of attraction, this is the force which is attracting an electron. Like if, for example, if there was since we are saying that there are equal forces of attraction and forces of centrifugation, which makes an electron to be moving around. So imagine that imagine that there was no force of centrifugation. There was only force of attraction, which is force of Colombian. The electron, if you imagine like that, you will see that the electron will possess a potential energy in such a way that it won't be moving. So we see that the force of Coulombian determines the potential energy of something. It is something which we see as force of centrifugation. This is the force of which makes an electron to move on itself. So we see an electron moving itself. There's a force of attraction which is attracting it to somehow to reduce its movement. So this force corresponds to the potential energy. So this force determines potential energy in simple. So how do you relate this potential energy to the force of Coulombian? So we see that we would say dV, the potential energy as it is, as an electron is moving, dV is just a differentiation, something like that. If you did integration, those things, yeah, to differentiate something, yeah, it's a differentiation of something. Yeah, I can say so. You differentiate something. So differentiation of V is equal to 1 over 4 pi E0 times E2 over R2, differentiation of R. So differentiation simply means at the movement, at each movement, the potential energy is somehow, if an electron is moving in an uniform form, and it depends with it, if R changes, if your R changes, if you come here, this is an electron. This electron is moving in a uniform uniform circle. It's moving in a uniform circle, and you have seen your R. This is your R here. So if you see this electron, its potential energy is different from this electron here. If you see this electron here is closer to the what? Is closer to this electron here is closer to the nucleus, meaning the R is different, meaning the R is the R of an electron will always be changing, and the potential energy will also always be changing. Yeah, actually, someone asked for an example of this, and yeah, actually, I don't have. I only have this diagram as an example. Yeah, I only have this diagram as an example. I don't know if it's clear or what. So, and actually, this one we just want to come out with the total energy, and it's not usually used in calculations. Like, it will just guide us to, there are some equations, very important equations, which I'll tell you you should know them by heart. Yeah, so we see that according to, since we said that potential energy depends on force Coulombian, and this force Coulombian depends on the what? The force of attraction depends on the radius of an electron to a nucleus. If an electron is closer to a nucleus, the force of attraction definitely is high. If an electron is distance far from a nucleus, the force of attraction is less. So, and if the force of attraction is less, it means the potential energy will be also less, and the potential energy will be also less. And if the force of attraction is high, the potential energy will be also high. So now we have this formula: dV is equal to 1 over 4 pi E0 times E2 over R2 dr. So dV is equal to force times dr. So force, this is force. This is the force of Coulombian. This formula, they are just replacing this formula by F, which is the force of Coulombian, which is this formula. So what do we do for us to find our V? So our V, when you want to find our V, you integrate, and you know how to integrate. You do. I think most of you did ADIMA. Yeah, I will try, even though for me I never did an ADIMA. So you integrate it. So when you integrate this one, you integrate your V. This one, E2 over 4 pi epsilon is always a constant. This one is a constant. So the only thing which you integrate is the R2, dr over R2. This is the thing which you integrate. And when you integrate it, it will give you -1 over R. This one we said is a constant. then negative 1 over r, when you just multiply it, your v will be negative E2 over 4 pi E0 r. So this one will be what? Your v. This is your formula for your v. So you might be confused. How do you get negative 1 over r? So I did some integration for you here. You should note that if you integrate dr over r to the power 2 is equal to, we just know that it's just the same as 1 r to the power 2 dr, which is just the same. If it is 1 over 1 to the r to the power 2, it's just the same as r to the power of negative 2. It's just the same as 1 over r to the power 2. And if you integration, is n plus 1. So you just add negative 2 plus 1, then you divide that one by the same, the power which you find. So negative 1 plus 2 also. So it will be negative 1 over negative 1, which will give you negative 1, which will be r to the power negative 1 over negative 1, which will give you negative r to the power negative 1. And which will finally give you negative 1 over r. This is where it's coming from, and this is how, after you multiply them together, you get negative E2 over 4 pi E0 r. I don't know if from here you have understood, or I should repeat.
Please repeat.
Yeah, so actually, I should repeat starting from the first point, or what?
Starting from where you started talking about the
NH total.
integration. The
Or
integration.
integration.
Yes.
But for the first part, I understood what?
Somehow.
Okay. And the Chikopoa, you can ask your question. Someone raised his hand. Okay, I think there's no question. So integration. So you have to integrate. For you to find v, you have to integrate the differentiation of dv. You have to integrate it. So when you're integrating it, we take this one E2 4 pi E as a constant. This one, if we multiply this together, it will give you E2 over 4 pi. Yeah, E2 over 4 pi. E is the what is what is the mass of an electron, which is always constant, you know. Then 4, then pi, you know, pi is always constant. Then epsilon, I think you are taught by Ernest that epsilon, this is the unit particle, which is, it's very small that it's variable. Yeah, so how can I say it? It's very small to know its unit. So they just take it as a constant also. So these all of it here is constant. The only thing which will be varying is the radius between an electron and the nucleus. That's the only thing which will be varying. So this is the thing which will integrate. That's where the integration is coming from. So when you integrate, the final answer must be negative 1 over r after you integrating. So I was saying, how do you get negative 1 over r? So you integrate s r over s, the sign of integration, r infinity, the dr over r to the power 2 is equal to, is just the same as 1 over r to the power 2 dr, which is just the same as if I write r negative 2, just the same as 1 over r to the power 2, which is just the same as r negative 2 plus 1 over negative 2 plus 1, which is just the same as r negative 1 over negative 1, which is, if you divide it, will give you negative r to the power negative 1, and which will give you negative 1 over r. I don't know if you are clear now. So this what gives you this, and when you multiply them together, it will give you your v. Since you have integrated your v, it will give you your v, which is negative E2 over 4 by E0 r. I don't know if you are clear now, or we should move on.
I have a question.
Yeah, you can ask.
Yes, yes. First of all, from the first equation, which is ET is equal to something, something, then there's a V.
There's noise there. I don't- Yeah, you can ask your question.
Yeah, I'm saying, since in the first equation we have ET is equal to something, something plus V multiplied by energy potential. So where is this V coming from and why are we using it? Then after you said this division, it means to differentiate this whole thing. Then what is the purpose of differentiating it and again integrate it later?
Oh, okay. So what I said, actually what I said, if you got me clearly, I said ET is equal to energy. They want to calculate energy total. And for us to calculate energy total, I want you to get me clear. First, to calculate energy total, we are calculating energy total of an electron which is in movement, in movement. And this electron, we know that according to the principle of physics, like the physics which we learned back at home, we know that energy is never lost, but is transformed from one form to another. For example, if I get a ball and I hold the ball with my hand, like I raise the ball. Before I drop the ball has a potential energy. But when I drop the ball, when the ball is moving, it contains two energies. That's kinetic energy and potential energy. Since we say that energy is never lost, but is transformed from one form to another. That's where 1 over 2 mv squared plus v. That's where energy potential is coming from. I hope that one you have understood.
Yes.
Then for differentiation, I said actually they had put a differentiation. It's not that they had solved it in differentiation. No, they had put a differentiation showing us that there's potential energy which is varying. Potential energy is constantly varying, and this potential energy is varying with the distance, the radius between the nucleus and the electron. And I gave you an example where if the electron is closer to the nucleus, it means that the attraction force, this formula, it represents the attraction. The attraction force is high, and if the attraction force is high, the attraction force we said is equivalent to potential energy. Potential energy will definitely be high. But if the distance of a nucleus and the electrons are far apart, the attraction energy is less, and the dV, the potential energy will also be less. So this is the formula which they give us. This is just the formula which they give us, showing that potential energy is in constant changing. Since you know that differentiation is something which is in constant changing. Yeah, so from that, they want to come out with an equation where there will be, they want to come up with an equation where there will be on V, where they will remove the differentiation from it, and it will only be what? It will only be V. That's why they integrated it. You know, integration is bringing it to its primitive form. So they wanted to bring it to its primitive form where you can calculate V on itself. So that's where they integrated it to have V on itself. I don't know if it's clear. It's clear?
I have a question.
Mm-hmm.
I wanted to ask about the radiation of the electrons, the ones that lose energy.
The radiation of it, yeah.
As in the electrons that lose energy, as they are in constant motion.
What?
I wanted to ask about the electrons that lose energy as they are in motion. Do they is there a sequence of how they lose energy, of how they might lose energy, or is it just or it's or maybe any electron at any time can lose energy faster?
Like the way they lose energy, they're moving in a sequence. Like they never said they are moving, like the electrons are moving in a sequence. They never said that this electron will lose energy than the other one first. No, but they said the electron, like as the electron they are moving, they'll be losing energy, and these electrons will definitely die. So there's no sequence of which one loses an energy first. And I will say that it was an assumption. It's not something which they demonstrated and they proved.
Thank you.
Yeah. And for this one, I'll ask, since we have got our senior prof here, he wants to clarify something on this one. So I'll ask Mwanza DM.
Yeah,
Clarify
right.
something.
Right. Thank you very much. Let's hope you guys are getting me clearly.
Yes.
Yeah. So
Yeah.
the thing is, like he says, energy, the total energy for an electron is the summation of its potential energy plus its kinetic energy, isn't it? So when you look at the principle, I don't know if you guys have done Rutherford's principle, and if you've also done Bohr's principle. I don't know. Have you guys done that?
We've
done Rutherford.
So when you look at Rutherford's principle, it explains how the electron moves from its orbit towards the center. That's the downfall of this principle, but that does not explain the movement of an electron. When you look at Bohr explains how the electron moves and how the orientation of an electron is in an atom. Like you look at the principle of energy loss and the principle of energy absorption, and you also look at the angular quantum number and all those things. But Jacob is going to explain. But the bottom line here is that when you're calculating energy all the time, like the energy principle is that energy is neither lost, but it is created from one form to another. So the energy that we're going to use here, because something is in motion, is kinetic energy and potential energy. So kinetic energy is equals to the mass multiplied by the velocity squared, then you have it, then plus the potential energy. Now the potential energy that we have here, because it's an electron, I don't know if you guys have done Coulomb's law in electromagnetic derivative. Like Coulomb's law states that you are supposed to get the charges, that is the potential energy for an electron multiplied by the potential energy for the proton, then you divide them with a radius squared, just like you look at the gravitational energy formula for calculating is it constant of gravity? Yeah. So the idea is the E that you're seeing here on the dV, where is it? On the F, the force Colombian. So the force Colombian is necessarily the force that the proton and the electron have in common. So when you look at the electron has a positive charge, isn't it? Or electron has a negative charge, and the proton has a positive charge. Now their relationship is F is equals to 1/4 the constant multiplied by the two charges. So E squared is the multiplication of the proton multiplied by the electron divided by their radius in between. Then dV here isn't a differential coefficient. It necessarily shows that, like Jacob says, it necessarily shows that there is a change in radius, because with Rutherford, he explains that an electron always moves from its outer orbital and goes towards the center, which is wrong. But here, the idea that is being explained is that as the electron is moving its orbital, it is possessing an angular angular momentum. So Jacob is going to explain angular momentum, or rather, you guys understand what angular momentum means when you look at principle, the Bohr. Yeah. So the dV just shows the change in the radius with relation to the electron and the proton. Then the integration part just shows the summation of all the parts. Like, let me give an example. If the shell or the orbital has got 6 parts, right? So we start from part 1, part 2, part 3, part 4, part 5, part 6. Then it goes back to part 1. So the idea here is we are adding all these parts. We are adding the changes in parts, the movement from part 1 to part 2 to part 3 to part 4 to part 5, part 6. So all in all, we are going to get the sum total of all the rotations. So integration can also be used as a summation. When you guys do integration analysis, you understand that integration at some point can mean summation. It can also mean addition. Summation and addition are the same thing. Yeah. So the idea here is the dV does not necessarily explain that there's a differential coefficient here. No, it just shows that there is change in a radius, and the integration is just used to show that as the particle is moving, as the electron is moving, with reference from the proton, there is change in the radius, and we are going to get the sum total of each change that we are going to have. Is it clear? Or there's another question? Then the last part here, which says donc ET is equals to E squared 4. So here we're actually making an equilibrium of two forces. So there is a force Colombian, which is E squared over the constant, and we also have the kinetic energy. So when we are making equilibrium of two forces, that is one force on the say x plus y is equals to 0, because at equilibrium there's nothing that is happening. So one of them crosses the equal sign, so that you have two net equations. Then from there, you solve it and make sure that you make one subject to the formula. At the end of the day, you have one uniform equation that stands for both the equations at equilibrium. Let's hope I'm clear. If there's any question, you can ask.
Let's hope it's clear. So basically, that's what I was trying to explain. And if you see in a simpler term or in a simple way, we can just say that there's a change in potential energy, and we have to find the what the primitive energy, the primitive potential energy, yeah, as Dalis was explained. So after we do all our differentiation, after we do all that, that's when it will come out. Our view will be like E2 over 4 pi E0 R. This will be our V. So yeah, so that's how it is simply about this equation. So this equation, like you don't even need to think about it, like to think a lot about it. Most important thing is you just have to know energy is equal to potential plus kinetic energy, and after that you have to know that there's the force Colombian, which is the force of attraction, which determines the potential energy, and this potential energy is continuous in varying, and for you to turn it on to V, you have to equate the varying potential energy to the force Colombian, which is this formula here. And someone asked what an E simply means. It is an electron. So you have just to differentiate to integrate this one, and after you integrate it, it will give you your answer, your V, which is negative E2 over 4 pi E. So this one is just, here we're just finding the we were just dealing with the potential energy. Hope it's clear.
It's clear. I also have another question. So you said since these equations will be applying them in the exercise that will follow, so does it mean that the most important thing is just to know this last equation, energy total, this velocity, this V plus, and this the force Colombian? Those are the most things we have to know, but not the way they were being connected.
Yeah, that's the most thing which is actually important to know. And actually, you will never find any question which asks you to find potential energy. I don't know if you find any question, but for me personally, I never found any question. But the most important thing is how you just have to know how the formula for the potential energy. That's the most important. If you just keep it by heart, you'll be able to solve. And if they ask you, find the potential energy for us. So that's the important thing. So don't, here we see that this is the formula for potential energy, and where there's V, we have found this, we just replace it to be negative E squared over 4 pi E0R. This is the formula. Now, as we know, as I said earlier, our main goal is to form a uniform equation. An equation, our main goal is to form an uniform equation. I mean that I must find a way of eliminating this and just form one equation, like to just be something which is together, the energy total. So for me to find the uniform equation, now I have to work with the energy kinetic, which is called energy synthetic. Yeah, just the same kinetic energy. Energy, yeah, energy kinetic. So how do I go about this one? So for energy kinetic, so yeah, for this one you have to know that force of attraction. This FA means force of attraction. Yeah, force of attraction or force of Colombian, they're just the same. So force of attraction can also be written in mv squared. Mv squared, this is the quantity of the movement of an electron over r at a certain distance. So this is the movement of an electron at a certain distance is equal to this formula for Colombian. I think you remember the formula for Colombian. This is the formula. So they are just equating. So for us, they introduce this formula so as to create something which will be similar to this one. They said they searched for a formula which will be same, which will have mass and velocity, and which will be same to the force Colombian, which is just as the force attraction, Colombian, just the same. Yeah, which will be similar to force attraction or force Colombian. So they found this formula in such a way that mv squared is the movement of an electron around the nucleus, and r, where it depends on the what radius. So how did they equate, or how did they bring these formulas together so that they find they find a way of changing this? So what they did first is, if you see, they just equated this one, mv squared over r is equal to 1 over 4 pi epsilon times e squared over r squared. So when they equated this one, the first thing is they wanted to only wanted to have mv squared. So for them to have mv squared, they multiplied by r everywhere. So if you multiply by r everywhere, this equation and this equation, meaning if I multiply by r here, meaning this r will cancel out and the r which I've multiplied. And if I multiply by r here, which means the r squared will cancel out to only have r. So this will bring us, just forget about the half, which this will bring us to mv squared 1 over 4 epsilon times e squared over r. Since we have multiplied with r, you have only remained with r. Then after that, to turn it to this equation which you are saying, this part here, this formula which you are seeing here, they just had to multiply by half. They multiplied by half here and they multiplied by half here. And after multiplying by half, they got something like e squared over 8 pi E0R. Yeah, this is what they got. So on energy total, they just replaced by what they got, e squared over 8 pi E-R minus E, then minus E. The first one, which they replace on V, e squared 4 pi ER. So you have seen they've got all of them, they've got the same what? Same, I can say same elements. There's E, there's A, there's pi, they are similar. So it's possible to subtract. So when you subtract them, you have this as your final answer, and this will give us the uniform energy, E total. So basically we did all that so that we have the E total. So the most important thing for you guys is to know the E total. Yeah, how you have to know the E total by heart, and the derivation, how it comes about, what, and most, like for me personally, I've never seen asking questions on Rutherford. Yeah, maybe by chance they ask a question, but they never ask a question on Rutherford on these equations. And actually, if we go lower, if we go like if we go forward, you see that these equations actually they are constant. They can't allow you to use these equations. They will just give you, they will calculate it for you already, then they'll give you as a constant, and you will just, like, they'll give you something. It will be something which is very simple. Don't be scared. No, there are a lot of differentiation, there are a lot of integration. So no, so this one is just, I'm just trying to show you that this is how we came up with energy total, and this energy total will be in future to be used in the formula for Bohr. So we'll see how we use it in formula for Bohr. I don't know if it's clear or what, or I should repeat. Is it clear or I should repeat?
Please, could you repeat again where it says Scherzer energy synthetic?
Okay, energy synthetic. Yeah, synthetic. I forgot an I here. So Scherzer energy synthetic. Energy synthetic. This is the kinetic energy actually. So here our main goal. I want you to picture this. Here our main goal is to form a uniform energy, like a uniform equation of energy, like this one, which is down here. So for them, they said you have to search for any synthetic. How can you search for any synthetic? So that when you search for it, you make it by all means to have the same elements as the energy potential, so that you form a uniform energy, a uniform equation. So how do you do that? So how they did that is, first they searched something which is similar to energy synthetic. They search energy synthetic here. So after the search, they found that the force of attraction, which is also the force of Coulombian, can also be written as in mv squared over r, where mv squared is the movement of electron, and the r is what is the radius between a nucleus and an electron, is equal to, they found that this equation is equal to the force Coulombian which we found with the equation which they gave us at first, if you remember. So they said, how can we make it? Can you get me now?
Yeah, we can get you.
Yeah, I don't know who entered my what, like he entered the account. everything was like there was a disturbance. So let me just, there's someone who entered the account. Let me just share. Yeah, you can see the screen.
Yes, yes.
Yeah, so there's someone who entered the account, I don't know who. So it had disrupted almost everything. So I was saying they were looking for how can we make this this formula as close as to this one. So they said, okay, let's first try by removing the error. So for us to try by removing the error, we multiply everywhere by error. So they multiplied everywhere by r to get mv squared, and after they multiplied by r everywhere by r, they got mv squared, and here it was r squared, we changed to r. And after that, they multiplied by half. After they multiplied by half here and they multiplied by half here, you find that this one, it has become equal with this equation, which is just the same as e squared over 2 times 4 is equal to 8 pi epsilon r. This is the equation which you get after you do that. Then after that, you just like your E total, you just replace it on your half mv squared, you just replace it. And since you have seen that they have got same, I can say they are the same in terms of there's an E here, there's also an E here. So it's possible for you to do calculation. So they subtracted, and the final answer was this one. So this one was the energy total, which was found here. I don't know if it's clear. I don't know if it's clear. I'll move on or what.
I have a question.
Mm-hmm.
Yeah, I can see two formulas for the energy total. So is there a difference in terms of usage for the one that's in green and the one that's in red?
Okay, so the one which is in green is the one which is like it was not yet finished. Like the one which is in green, we have only found the potential energy, like the formula for potential energy. We haven't found for kinetic energy. So the one which we usually use is the one which is down here, where we also calculate for potential energy, then we form a uniform one. So the one which is used is the one which is in red.
All right, thank you.
Mm-hmm. So yeah, so that's also this one, this energy total, it will just help us to calculate. You see when you go down, it will help us to form our energy when an electron moves from one shell to another. You see how we do that. Yeah, so here we do, like today we do a bit of mathematics, and I know it's a bit confusing to you guys, but these are things which are simple things, and if you just know how to go about it, and if you just understand it, yeah, you'll be able to answer almost any question. So, but that are movement circular uniform. So you should know that in a movement circular uniform, the force of this force, the force of I said this force of attraction is similar or is always equal to the force of Colombian. Yeah, that's what you should do always know in a what. Okay. So Dan wants so someone asked I should tell you the meaning or the what of variables. So I've got E squared. E is an electron, the mass of an electron, which you know, 9.1 times 10 to the power 31 kg. Then pi, you know, all of you know pi. Then epsilon, this is just the smallest unity, which it cannot even be calculated. Yeah, it's not even known. They just say an unit which is small. Then R is the radius between the electrons and the protons. Yeah, that's basically. I don't know if, yeah, I've answered your question.
Can you just explain on MV circular uniform there how you did your replacements and how you came up with that formula just from MV circular uniform? Yeah.
Yeah, for this one, I said, I think you understood when I said first you have to just make it mv squared by multiplying by r on both equations. So after I multiply by r here, and when I multiply by r here, it gives me mv squared. It gives me 1 over 4 pi epsilon times g squared over r. So how did it all come about? So it all come about by, we want to make the equation similar as possible to this one here, kinetic energy. Then if we want to make that equation similar to kinetic energy, meaning we'll just multiply by half, the half which is here. So they just multiplied by half and they multiplied by half. Yeah, just that's simple. So that's how they did. So after multiplying by half, they had something like 1 over 8 pi epsilon times e squared over r. So if you multiply this together, we have e squared over 8 pi epsilon r times e squared over 4 pi e r, which is this one here. I don't know if I've understood.
Oh, yeah.
Also, yeah, so so MV, he was ask why MV disappeared. So the main basis of like here MV squared, I'm saying half MV squared is equal to this one. So the main basis was for me to have this equation, have this equation here. So after I have this equation, I've known that MV squared is equal to this equation, which after I multiply. So where there's MV squared, since I know that is equal to this one, I will just replace where there's MV squared here. That's why I've replaced it here. Yeah, that's how you are seeing MV squared. So this MV squared was it was just leading us to our equation, which you give us our final equation in terms which will give us something which has similar variables. Yeah. I don't know if it's understood. Can you move on or what?
Yes, you can move on.
Yeah, so we'll move on. So these relations, relations qui permet, on va voir, relations qui permet d'exprimer ET soit en fonction du rayonnement R d'orbite, soit en fonction de la vitesse de l'électron. So this relationship, this is a relationship which permits us to express this relationship. It permits us to express energy in function of R, which you said R depends on the potential energy, which is, so they're just simply telling us that the energy total is expressed in function of R, which is what? Which is the potential energy, and in function of the vitness, which is the kinetic energy. And after, yes? Yeah, okay. So which is the kinetic what? Which is the kinetic energy. And this how like for you to find the energy of an electron, they are just simply telling us you have to consider the thing which I explained earlier. You have to consider the kinetic energy and the potential energy, and that's when you do your calculations, you do your everything, you form a uniform equation which will give you E total. That's what this one is simply explaining. And they said for this one, for you to calculate this one, there are two things. There are two things which you are supposed to put in mind. The atom of hydrogen is stable. The atom of the hydrogen is stable. So what do they mean? They don't mean, you know that atom of hydrogen has 1 electron in its outermost shell, which implies that the atom of hydrogen in itself is not stable. So when they say the atom of hydrogen is stable, it means that the electron which moves in the atom of hydrogen, its force of attraction and the force of centrifugation must always be equal, in such a way that if the force of attraction and the force of centrifugation are equal, the electron will be moving. And they must also put in mind that the spectra, the emission, the hydrogen, and in spectra, the rays. So they should also put in mind that the spectra of hydrogen must be the spectra of rays, which Rutherford himself failed to explain to us. The spectra of rays which model the Bohr will explain to us. Yeah, so basically that's all about Rutherford. And Rutherford, so what you should do on Rutherford, what you should do, the most important part, what you should know on Rutherford is how he discovered an atom. He discovered an atom as a space. And you also have to know the problem which Rutherford had. Those are the principal things. The problem where he said an electron itself is moving, and which means that somehow it's losing energy in form of radiation. You have to put that in mind. Then the other thing is you have to put in mind the total energy. The total energy which was what? Calculated, the potential energy which was calculated, the final potential energy, and the total energy which was calculated. We'll see that with Bohr, for him, he'll explain more of this same process, and he will shed more light, and he will make the formula of Rutherford better in such a way that he'll be able to solve the problem of the radiation. Yeah, he'll be able to solve the problem of the radiation. So for that, you just have to know that equation. And most of the times, most questions come on Bohr. Most of the time, most questions come on Bohr. And yeah, that's the topic which has a lot of questions, and this is the topic which you have to know. Yeah, you have really to know. Rutherford is just, I can say, just a base which brings us to Bohr. So Rutherford is just a base which brings us to Bohr, and Bohr is where a lot of questions comes from. So for Bohr, you have to pay particular attention on it. So model de Bohr. So for model de Bohr, actually I wanted to make the model, le modèle de Bohr ne permet pas, le modèle de Rutherford ne permet pas d'interpréter le spectrum d'émission de l'atome, the hydrogen. So we see that the model of Rutherford does not permit us to explain or to interpret the spectrum of emission of an atom. Spectrum is simply release of different, a spectrum is a bunch of different colors, like a release of different radiation with different colors. Like he couldn't really explain that about the radiation having different colors. Like he couldn't explain that, which we see Rutherford would do. There's an experiment which Rutherford did. So I want you to follow me on this experiment. Yeah, there's experiment for Rutherford. So this is an experiment for Rutherford. So Rutherford, what he did, he got a hydrogen gas. Then this hydrogen gas, he had put it in a I can say he had put it something like a closed sphere. Yeah, he had put it in something like a closed sphere, and he created what? A circuit in such a way that this circuit, this sphere was under under Febrile pressure. Febrile pressure is low pressure. It was under low pressure, and the generator, there was a generator down, which was creating an electric charge. So this generator, when it created an electric charge, Bohr discovered that the hydrogen itself, the hydrogen gas, released different spectrum, like there were radiation of different spectrum in such a way that there are radiation of different colors. And these radiations, when these radiations were released, he also discovered that the radiations had different longitude, and you know, longitude is wavelength. Yeah, wavelength. They have got different wavelengths. So he noticed that there was those with small wavelength. He went about wavelength in physics. The wavelength. This is the distance of one crystal to another crystal. Like, you know how to make a wave, the distance between one crystal to another crystal. So he saw that there are some radiation which had small wavelength, and some radiation which have long wavelength. And as we learned from our secondary school, we know that if something has small wavelength, it implies that the frequency is high. If you get X-rays, we started with the radio waves, which have got high wavelength. Then we went down X-rays, which have very, very small. The distance between the two crests is very small. So we saw that X-rays is actually we can say gamma rays, X-rays, they are very dangerous because their frequency is very high. The frequency of gamma rays and X-rays is very high, and that frequency is correspond with the wavelength. So if the wavelength is low, the frequency is high. And if the frequency is high, it means the energy which you possess must be high. So he discovered that they've got this different wavelength. If they've got different wavelength, he also discovered it means that they must have different frequencies. If they have different frequencies, it means that they must have different energies. So with this reasoning, or with this theory which he had, he brought out something which is called postulate de Bohr. So postulate de Bohr is simply an expression or an assumption which tells us something. This is an assumption, or this is an assumption which tells us that there is something existing by when a person just reasons. So postulate is him reasoning that because after I've done this experiment, I've found that I've found different radiation. I've found a radiation disperses different colors which have got different wavelengths. So it means that one, there must be different frequencies, and two, there must be what? Different energies, which brought him to think of this postulate de Bohr. So we're going to look at this postulate de Bohr, what brought him to discover according to the experiment which he did. So now that's when that one was just according to the experiment. Now we'll go to according to what he discovered. So we see that according to what he discovered, he formulated something which is called postulate de Bohr. So what does postulate de Bohr simply tells us? So we see Bohr a été donc amené à améliorer ces modèles planétaires et à formuler un certain nombre de postulates. C'est le model atomic de Bohr. So we see that Bohr himself wanted to wanted to make the model of Rutherford beta, and after in wanting to make the model of Rutherford beta, he did that experiment which I'm from telling you, where he found different spectra. So when he found different spectra, he came up with postulate de Bohr. So what does postulate de Bohr says? So postulate de Bohr says, the first one says, les électrons ne peuvent se placer que sur des orbites circulaires de énergie bien déterminée. So he said, he thought, like he had an assumption, he reasoned to himself, since I found that they have got different wavelength and they have got different frequencies, they have got different energies, which means that each electrons, for him, which means that each electron is placed in a well-determined orbit circular. Orbit circular is a circle orbit. This is a circle orbit. If you see for Rutherford, there's no a thing like a circle orbit or what. For him, he just said electrons were moving around, but we see Bohr for him with his knowledge of different spectra of having different energies. He discovered that there are shells in which an electron is placed, and each electron has got a definite energy in its shells. So according to him, he said these energies represent, this is the first energy level, which is 1n, first shell. So in this shell, the energy for this electron is well determined, is always constant. Then he also discovered, since he said there are different energies, meaning that there will be different shells, he also discovered that there will be a second shell, which the energy also will be determined to be different. So if you find an electron here, it has a defined energy. If you find an electron in the second shell, it has a defined energy also. If you find an electron in the third shell, it has a defined energy. So this is what led Bohr to have this discovery. So this was his first reasoning. And after that, he thought that lors des sauts mouvements sur une orbite circulaire, l'électron est dans une état stationnaire. So Bohr said that during their movement in this orbit circular, the electrons are in their state stationary, their state stationary state. Stationary state meaning the electrons are not moving in such a way that I want you to get this one. I want you to get it clearly. Under Rutherford said the electrons, they are moving by themselves, and according to the theory Classique, which we said, if an electron is moving by itself, it releases radiation and it releases energy and it will die. But for Bohr, he saw that was a mistake. If an electron is moving by itself, it can die. But let me create something in such a way that this movement, this electron must be stationary. What will be moving is the orbital. So the electron is not moving, it's stationary. But what is causing it to move is the orbital. So just imagine the way the sun is. The sun is on the middle, and we've got the planets around. We have got our planet Earth. It is around the sun. So what usually happens? The Earth itself is stationary, like doesn't move, but it is the orbital which is moving. So which means that the energy which is done by electron is zero. For example, let me give an example. Like if I say today I want to move from Fez to Rabat by walking, that's the first formula of Rutherford. Rutherford, for him, he said the electron is moving by itself. So if I want to move by my legs, like walking to Rabat, it will happen that I won't even manage. I won't even reach even half. I'll be exhausted, and if I don't have something to eat or water, I might die. But if I say today I want to come to Rabat, I'm going to sit in a bus and I'm coming to that side. You know that I'll actually reach that side because the work which I'm doing is almost zero. The energy which I'm doing is almost zero. I'm just seated. The thing which is doing the energy is the car which is taking me that side. So this was the thinking of Bohr. Bohr thought that this electron actually is just seated stationary on the orbital, and it's the orbital which is making it to move, meaning the loss of energy by emission is omitted. I don't know if it's clear.
Huh?
I don't know if it's clear.
Yes, it's clear.
It's clear.
Clear.
Yeah, so the electron must be placed in different energy levels, and the movement of electron is, the electron is stationary, and it is this orbit which is moving around. So that's what you should get. So that's how Bohr, that's how Bohr had reasoned. Then the second postulate, he said that those the electron passes on orbit stationary N on orbit M on a emission or absorption de l'énergie électromagnétique. So he also brought another postulate which said that if an electron, let's say an electron is on the energy shell, the first energy shell, which is stationary, let's say it's here, which is stationary, and it passes from this orbit to the outer orbit, there will be an emission and absorption of energy electromagnetic. How does that happen? So this one usually happens by, for example, what usually happens is when an electron is, we imagine the electron is in this first shell. So what usually happens is when an electron is in this first shell, there will be some energy which will be coming from exterior. This what we call photon energy. I want you to get clear. So the energy, imagine photon energy. Photon energy, this is simply an energy which is carried by a photon, and a photon is, those are like small particles which makes up light. So we can just say energy which comes from light. When I say photon energy, I mean energy which comes from light. So when this photon energy comes, it will come to the electron. And imagine our electron here, it's coming to the electron. Then when the electron absorbs this energy, the photon energy, the absorption, it means it will jump to the outer shell. If you absorb an energy, like if something absorbs an energy, it is excited, it becomes excited, and if it becomes excited, it means it will do an absorption, it will absorb that energy and jump to another shell. Then if, let's imagine there's an electron which is moving in the outer shell. Yeah, there's an electron which is moving in the outer shell, the electron, and this electron loses a photon energy. If this electron loses a photon energy, it's called, it has emitted a photon energy, meaning it's called emission. It will go back to the first electron. Yeah. So yeah, so someone asked a question. The question was, he concluded that electron is stationary in that it's only moving in its orbital, or that is at one fixed point in the orbit. So he concluded that the electron is stationary, is on one fixed point in such a way that the electron is on a fixed point, it's not move, is stationary on an orbit, but the orbit is the one which is moving an electron. So the electron itself is not moving. It's like it's just stationary. It's at the same point. And the orbit is the one which is moving the electron to, I can say the position of an electron is always the same, to put it in this way. The position of an electron is always the same, but on the orbital, but when the orbital is moving, it moves with what? The electron. So where the electron was will be always the same, will be always the same, but when the electron, when the orbital is moving, like I can give yeah, I can give an example. So this is the position, this is the fixed position. But when this orbital is moving, let me say this orbital starts moving, the position, it will be, the position is all stationary, but because the orbital is moving, the position will definitely change, but there'll be no energy. This position maybe will be changed to here, what, but the electron itself is always stationary. What's causing it to move is the orbital which is moving. I hope you have got me clear.
Yes, it's clear. Thank you.
That's all about it. So as I was explaining, when an energy comes, an electron absorbs that energy. That's the absorption. If it absorbs that energy, it will go to the outer shell. It will be excited, like when you have energy, you are excited, and it will jump to the outer shell. Then when it releases that photon energy, it will be excited in such a way that it will go to what? To the inner shell, which is emission. Yeah, that's all about the postulate the Bohr. So the postulate the Bohr, the first one, he said when an electron passes from orbital N to an orbital M, we have emission or absorption, the energy. So we'll look more in detail on absorption and emission, and we'll see how to calculate these things. And yeah, and actually these are the very simple things in terms when it comes to calculating. Like, it's very simple. It's very simple. And most we will do with like questions mostly is on calculations. Yeah, so you should know that this is NHM minus NHN is equal to HV. So NHM, this is, as I said, each shell has got different energy. So let's say it has moved from the inner shell to the outer shell. So if it has moved from the inner shell to the outer shell, we will say that the inner shell is NE, and the outer shell which it has moved it is EM. So EM is the outer shell where it has moved to. Then EN is the inner shell which it has come from. So which is always equal to HV. So don't be confused when you see HV. HV simply, this is the energy of photon. The energy of photon which is absorbed for it to move from this stage to this stage. So HV is the formula to find the energy of a photon. So the energy of a photon is equal to HV, where H is constant de Planck, and constant de Planck is always they always give you is constant. It's a constant which they always give you. So you have to just know this one by heart. Then V, it means what? Frequency. So the movement of an electron from the outer shell, it depends on the frequency. There are some questions. Someone asked a question: does absorption and emission happen to group 8 elements? Group 8 elements. Those are elements which are stable, if I'm correct. Yeah, so for group 8 elements, the absorption and the emission. So your question, you're saying, does absorption and emission happens for a group 8 element? So absorption and emission is generally described, it's generally described for an atom in general. Yeah, an atom in general. Even though yeah, it generally describes an atom in general, like an atom when it absorbs energy, an electron in an atom in general, when it absorbs energy, it moves in the outer shell. So for that absorption and emission, yeah, it usually happens, even though it's, we can say it's really stable, but Yeah, so even though we see that group 8 elements are really, really stable, but it can happen because absorption is when it absorbs energy, like something is forced to move because it has absorbed energy. So that thing can happen. I don't know if it's clear.
It's clear.
Yeah, then for this one who asked, so the outer shell has more energy. This one will answer it when we come down. Actually, you see, this is the interesting part which I want you to see. Yeah, so about the energy, you will find that the one which has higher energy is the inner shell, not the outer shell. The outer shell actually has less energy, even though what usually happens here is an electron absorbs energy, and that energy is only used for it to move to the outer shell. That energy is not either when it moves to the outer shell, that energy is the energy which is used to move is completely used up. So you understand more when you go to look at these energy levels in more details. That's the thing which we're supposed to look like. That's the thing which we really need to concentrate. Like that's where most of the questions come from. That was really a nice question. So energy level, the one which is the inner energy, the N1 has high energy level than the N2. You know why I'm saying this after we do some equations. And yeah, I hope I've answered your question. I hope I've answered your question.
Yes,
Then what do the symbols EM and EN stand for? So EM is just stands for the energy levels, like the energy levels. It just stands for the energy levels. EM, when you see in chemistry, when you see EM, EN, E1, E2, E3, it means the energy levels which determine each shell. So when I say EN, I can say EN, for example, in terms of absorption, EN, this one will be my EN, where I'm starting from. Then EM is where the electron goes. But in terms of emission, my EN will be this one, where you're starting from always, that's your EN. Then your EM will be the inside one. That's why most of the times you'd find emission as, if you are calculating emission, sometimes you find the energy negative since it has lost energy. Yeah, so that's all. Then we don't really have time with us, so for today we'll end from here. Yeah, even though I wanted us to do almost to finish with, yeah, but there are a lot of questions. So this topic basically has a lot of questions, so I would advise you to pass through, and after you pass through it, yeah, you can ask me any question about this, the same things, the same questions, the what, so that I explain it to you more. And actually, I didn't reach where the question starts from. I didn't reach the part where the question starts from. So when you reach that part, that's when I'll give you questions. Today I was planning to reach that part where the question starts from. No, now due to time and I knew that it was what the topic is very involved in terms of integration. You'll be wondering why is this coming from, why. That's why it even took me time for me to reach where I am. So we hope by Monday we'll be able to finish with this topic. Yeah. So before we go, there's someone has raised the hand. You can talk. I don't know if it's Kondwan or what. The one who has raised the hand. Okay, so I
think
say,
it was just a mistake.
yeah, it was a mistake. So, yeah, so for today's, that's all. I just advise you to pass through it, and next time we'll start from here. Yeah, we'll start from there, then, yeah. Then, yeah, have a good day, everyone. And the questions, we'll do the questions when we reach the part where the questions come from. So those were just the basic things. Yeah, have a nice day.